Maths educational video, an introduction to power series. First, the definition. As you can see, a power series is an infinite series. We are summing this term c:x power k for k from 0 to infinity. Now, x is a variable. So you can think of this as a function of x, provided it converges. The numbers c0, c1, c2, and so on are called the coefficients of the power series. A more general form of the power series is obtained when we replace x with x minus a constant a. A is called the center of the series. This more general form is useful for certain applications. As I just mentioned, we can treat this as a function of x, provided it converges. So later we will look at the issue of convergence. But first we look at a familiar example of a power series. This is a geometric series with common ratio x. But it's also a power series because we are summing x to the power of k. And if you go by the definition, the coefficients, the numbers before x power k, are all equal to 1. The issue of convergence is important because if a power series converges, it is a function of x. We can then do things like differentiation or integration, which we will explore in subsequent videos. Convergence of power series is a deep topic, typically covered in advanced calculus courses. So here we just go through the 3 possible cases that we'll encounter. Given a power series, one of 3 cases will hold. The first 2 cases are the extreme cases. Case 1 is when the power series will always diverge, except for one obvious choice, x equals to little a. If you substitute x equals to a, most of the terms become 0. In fact, only c0 survives. So when x equals to little a, the power series will be numerically equal to c of 0. But other than this special case, the power series will diverge. So this is the first case. The second extreme case occurs when the power series converges for all x, which means whatever x you substitute into the power series, the resulting series will always converge. So this is the second extreme case, and this is the best scenario. Obviously, there should be a third case, which is something between case 1 and case 2. And it turns out that in this case, the power series will converge provided x lies in some interval. And in this case, an interval surrounding the center of the series A. Capital letter R is half the length of the interval, known as the radius of convergence of the power series. So summing up, when given a power series, one of the three cases will occur. And in the subsequent videos, we will learn the techniques for determining which case it belongs to. And for case 3, we will learn how to find the value of R. We end the video with another example of a power series, which is also a geometric series. I'm using this to illustrate the concept of radius of convergence. It's not hard to tell that this is a geometric series. Common ratio is 2 times of x minus 1. Let's recall the condition for a geometric series to converge. If the geometric series has a common ratio r, it will converge if the absolute value of r is less than 1, and diverges if the absolute value of r is greater than 1. So if you replace little r with 2 times of x minus 1, then we will get the radius of convergence half, because it converges if the absolute value of x minus 1, the center of the series, is smaller than half, and diverges if is greater than half. So this half is exactly the value of r that we are looking for. If you refer back to this slide, for case 3. We end the video with 2 remarks. The value of R is set to be 0 in case 1. That's where the series always diverges except at the center of the series. And in case 2, if the series always converges, we take R to be infinity.